All right, boys and girls, here's another video. This is lesson 7.6. We're going to use algebraic expressions. Our objective is I can use algebraic expressions to solve problems. So, here's a little warm-up for you. I want you to do this in your notebook. Make sure you actually complete it. I have 3 expressions for you. And your job is to solve them if t equals 7. Go ahead and pause the video, and then you may watch to check your work. Okay, so hopefully you've solved them. Let's go ahead and check your work. So looking at this first equation here, 5t plus 8 equals something. When we evaluate, we solve the expression. So t in this situation is going to equal 7. T is our variable, okay? Remember that our variable, t, is in this situation being times by our coefficient 5. So we really have 5 times t, or 5 times 7. So let's go ahead and rewrite this. If we have 5 times 7 plus 8. 5 times 7 gives me 35, plus 8 would give me 43. So that's the answer for the first one. Let's go ahead and look at the next one. We have 2t plus 3t, and each of those t's is actually represented by the number 7 because of the variable. Remember, variable means to change, so this t can change, and right now it is a 7. So what we actually see is 2 times 7 plus 3 times 7 equals. And of course we want to do the order of operations, so we'll multiply first. 2 times 7 is 14. And we're not going to add yet because we still have another multiplication. 3 times 7 is 21. As we add those two together, it will give us our final answer of 35. Excuse me. And then our last warm-up problem, we have parentheses, so make sure we did those first. We have here 4t, or 4 times t, or 4 times 7, and then in parentheses 20 minus 6. Remember, we want to do this parentheses first. So let's go ahead and let me get my pen. 4t times 20 minus 6 would give me 14. Now I'm going to go ahead and do my multiplication here. 4 times 7, and then multiply that by the 14. 4 times 7 is 28 times, and when it's in the parentheses like that, that means to multiply it. So 28 times 14, do that work over here. 32. 4 times 2 is 8, 9, 10, 11. 0. 1 times 8 is 8. 1 times 2 is 2. Add them together. 2, 9, and 3. So I received the answer of 392. Hopefully you did well on those warm-up problems. If not, feel free to pause, rewatch, ask me, or Mrs. Howell. Okay, quick review on some of this vocabulary. We have expressions. Here's my little word bank down here. When we're talking an expression is this whole problem, you could call it. This whole thing is our expression. 3a plus 2b minus c. When a problem asks you to write an expression, they're looking for something like this. Not necessarily an answer, but an expression is kind of like writing the problem yourself. Within our expression, we have a couple of vocabulary words. Our terms. So these are terms separated by the addition and subtraction. 3a is a term, 2b is a term, and c is a term. Okay? So those are our terms. And then inside of those terms are our variables. Here we have the variable a, b, and c. Okay, so variables are, switch here, the letters. And they can change depending on what the problem gives us as our variable. The last one is our coefficients, which is the number being multiplied by the variable, such as 3, 2, And this one, it doesn't have anything listed, so technically it's 1. And that is the number multiplied by the variable. Multiplied, sloppy handwriting here, by the variable. Okay, hopefully that's just a review for you. So let's go ahead and get started into the actual lesson now that we've had our warm-up and our review. Here's our first example. Now you'll notice that this is example 1A. It goes on the left side of your notebook. There will be an example 1B as well, part 2. Okay, so here is the story problem. Mr. Twisdell makes and sells candles online. This is not a true story problem. He charges $7 per candle plus $5 per order for shipping. Shipping is how much it costs to mail it to the customer. So we're going to write an expression Mr. Twisdell can use to find the total cost for any of his candle orders. Look here, write an expression. They do not want us to solve it. They just want us to write the expression, write the rule. What formula or what expression, what rule can I use to find the total cost for his order every single time, regardless of how many candles are ordered? So first of all, we need to talk about how much does each candle cost. Look back into our story problem. Makes and sells candles online. He charges $7 per candle. So the charge per candle is $7. Now, depending on how many candles they buy, that's what we're going to multiply that by. Say if they bought 2 candles, then it'd be $14. If they bought 3, it'd be $21, so on and so forth. So here's our multiplication. I could have put a multiplication sign, but I did the dot instead because, remember, they're the same thing. And really, it depends on how many candles they order, so we want to use a variable here. I could use any numbers, any letter to represent my variable. I'm going to use N. I could have also used C for candle. Sometimes that could have been a good idea. Doesn't really matter. I went for N for number, but again, it doesn't really matter. We could have used X, we could have used J. But this is our variable because this number will change depending on how many candles each person orders. But regardless of how many candles they order, it'll be $7 per candle, and each order we're going to add the shipping charge, which we look back in our problem is $5 per order. So here we have $5 per order. So our total formula, complete formula is 7n, or 7 times n, plus 5. That is my expression that I'm going to write. I cannot solve this yet because I don't have enough information. I don't know how many candles anyone bought. So for now, this is as far as I can get with this problem, and that is what it asked of us. It asked us to just write an expression. So here's example 1b. So just do it right underneath example 1a because it's a continuation. So now we have our formula. I've already listed it here. And let's see what we're going to do with it. In September, one of Mr. Twisdell's customers placed an order for 4 candles. In October, that same customer placed another order for 6 candles. What was the total charge for these orders? Okay. Sorry, for some reason let's see if I can make this appear again. Okay, what was the total charge for both orders? That's our question that we're looking for. So, let's take a look. We need to break this down. In September, whoa, that wasn't supposed to happen. In September, they ordered a certain amount. So, here's our formula. They ordered 4 candles in September. So, I have my formula 7, and 4 is our n, plus 5. Let's go ahead and see how much it cost them. 7 times 4 plus 5. 7 times 4 is 28, plus 5 equals, cost them $33 in September. In October, and remember, I just got my 4 from the story problem. It told me how many they bought in September. In October, that customer bought 6 candles. I guess they really liked the candles that Mr. Twisdell can make. We have 6 candles, and they cost $7 each. So 7 times 6 and then plus $5 in shipping. 7 times 6, right here. Oh geez, I'm having a mind blank here. 42, there we go. It's late, sorry. Plus 5 equals $47. Next, they didn't ask us how much it cost them for the 2 months, but a total for both orders. So I need to take my 33 and my 47 and add them together. So 33, so September's order plus October's order equals the total charge for both orders, or $80. Someone spent a lot of money on candles for 2 months, but they must have smelled really nice. So that's how we would solve this equation. So a step further in this example, my question for you is, could we have just added the candle orders? They ordered 4 in September and 6 in October. Could we just add those together and have solved the equation once for n equals 10? Adding 4 and 6, saying, well, let's just solve it once, n equals 10. Yes or no, and why? Pause the video here, jot down your answer. The best way to figure this out, solve it for 10, see if you get the same answer. Okay, let's go ahead and solve it. If I had 7n plus 5, which was my formula, if I would have just solved n equals 10, it would have been 7 times 10 plus 5, or 70 plus 5, or $75. But we know that it actually cost $80. Where did we lose $5? In the shipping charge. Because if we just added these together, that's like saying it was one order of 10 candles and we only paid one $5 shipping charge. You see that? But in fact, they made 2 orders and each order has a $5 shipping charge. And if we would have done, as we did in the original problem, if we would have done 7 times 4 plus 5 and 7 times 6 plus 5, it gives us $80. Not $75, because we lost the shipping charge for trying to do it all in one go. Okay, here's another example, another 2-part example. So this is 2A. Again, not a true story problem, but kind of fun anyway. Let's imagine that Mrs. Howell sold the pumpkins she grew for $7 each. She grows pumpkins in her yard. She sells every single one, costs $7. Okay, write an expression or a rule to represent the amount of money in dollars Mrs. Howell made selling pumpkins. Tell what your variable represents. So in this example, they didn't tell us what variable to use, so we get to, we get to choose what our variable is. So Mrs. Howell sold pumpkins that she grows for $7 each. I'm thinking what operation to use. If I had 6 pumpkins, how much would it cost? Well, what operation did I use? 6 times 7 would be 42. So I'm using multiplication. So this is actually a really easy expression. All it is 7 times your variable. And I'm going to use P for pumpkin, because that's what I did. No matter how many pumpkins she sold, I multiply it by 7, and that gives me the amount of money she earned. Money earned. See that? So our expression is 7p equals the money earned. So if she sold 2 pumpkins, it would be $14. If she sold 3 pumpkins, $21. Regardless of how many pumpkins she sells, we just plug in that number for P, and it will tell us how much she earned. So let's take it a step further. What if Mrs. Howell sold 30 pumpkins? How much money did she make? Here's my formula. I copied it down. 7p equals the money she makes. So all I need to do is substitute this 30 in for P pumpkins. So all I need to do is 7 times 30 will equal the money that she made. well, what is 7 times 30? 7 times 3 is 21. Add a 0. So she made $210. And let's put a dollar sign because this is money. She made $210 for selling 30 pumpkins. Obviously, we need to get into the pumpkin selling business. Okay, another story problem. This one is a try it, so it goes on the right side of your paper. Make sure you pause after I read the problem to try it on your own. Mrs. Delgado is designing a building. Not a true story problem, but it's kind of fun to imagine. Each floor, now that's, you guys know what a floor is, like how many stories it has or how many layers. Each floor will be 12 feet tall from floor to ceiling. Write an expression for the numbers of floors a building can have if it represents the if H represents the total height of the building. Meaning, if the building is so many feet tall, how many floors could we divide it into? Go ahead and pause it. Try and write an expression on your own for this story problem. Okay, this one is a little bit trickier, but let me help you out. Let's draw a picture. Let's say that her story, or her building, is, let's just say it's 120 feet tall. That's nice and easy to work with. Because if it's 120 feet tall, and each floor is 12 feet, how many floors is she going to be able to make? The answer would be 10, right? Because we are taking this number and dividing it by 12. So whatever our height is of the building, we're dividing it by 12 feet to give us our number of floors. An easy way to remember this is if you're trying to make a smaller number than you started with, you'll divide or subtract. If you're trying to make a bigger number, it'll be multiplication or addition. So this is your expression, H divided by 12. So, try it part 2. What if the building is 132 feet tall? Then, how many floors can it have? I went ahead and wrote your expression down for you. It's H divided by 12 equals the number of floors. Go ahead and solve the equation and then watch me solve it. Okay, so we're going to substitute in for H. We're going to substitute how tall the actual height is. It's 132 feet. If I divide that by 12, which is the number of feet each floor is, it will give me, the number of floors, the number of floors. Whoops. There we go. So all I need to do is a quick division problem. 12 goes into 132 how many times? It doesn't go into 1. It goes into 13 one time. Bring down my 2. Goes into 12. 11 times. Goes into 1, yeah. 11 floors. Meaning that if I was to build a 132-foot building with 12 feet floors, there would be a total of 11 floors. So you'd probably want an elevator in case you had to go to the top floor. Hopefully you guys got that one right. If not, please ask me questions because I can help you with this. Okay, this is very important that you understand how I solved these problems. Okay, this is the last example, and then we'll do one more try it problem, and then we're done. So stay with me. Example 3, going to be on the left side of your notebook. You're going to write an algebraic expression. So you're writing an expression. Then, so there's 2 steps. Evaluate the expression for these values of the variable 1, 6, and 13.5. So you actually have a lot to do. First, you have to read this, write an algebraic expression, and then solve it 3 times, once for 1, once for 6, and once for 13.5. Let me show you what that's going to look like. Okay, so this is going back to 7.3 last week. The quotient of 300 and the sum of b and 24. So they want you to write your expression first. Quotient means divide. So I'm going to do 300 divided by, and the sum of b and 24. Sum is addition. Okay. Now what I don't want to have happen is I don't want to do 300 divided by b. I want to do b plus 24 and then sorry, I want to do b plus 24 and then divide it by 300. So I'm going to be really smart and put these in parentheses so they don't get split up by the order of operations. So b plus 24 first, and then whatever I get from there, I'm going to divide by 300. Okay? So let's go ahead. This is our first step. All that we've done so far is we've written an algebraic expression. Now we need to evaluate that expression for these values. First, what if b equals 1? So if b equals 1, I'm going to solve this. 300 divided by, I'm going to substitute in 1 because b equals 1. 1 plus 24. More operations, order of operations practice. 1 plus 24 is 25. 25 divided by 300. Well, I know there's 4 quarters in 100, so 4 times 3 is 12. Okay? If you're not sure how I did that, you can always solve it by division on the side. So, now I've solved it by 1. Next, I need to solve what if b equals 6? Same equation, same expression, but now I'm going to solve for b equals 6. So I have 300 divided by, not b, I'm going to put in a 6 here, plus 24. Okay, now 6 plus 24 comes first because it's in parentheses. I'm going to rewrite 300. 6 plus 24 is 30. 300 divided by 30, cross off my zeros, 3 divided by 30 gives me 10. Okay, so that's how I would solve it for b equaling 6. So now I've done 2 of these. Okay, the last one we have is 13.5. Now because I've run out of room, I'm going to just make a new slide here. Let's see if it'll... Okay, so let me rewrite the formula. 300 divided by b plus 24. In this example, b equals 13.5 or 13 and a half. So let's go ahead and plug that in. 300 divided by 13.5 plus 24. Do that math on the side. 24.0 plus 13.5. Make sure I line up my decimals when I'm adding. 37.5. Now, that tells me what I need to do is 300 divided by 37.5. So, confession, I solved this one and I got stuck and I actually had to pause the video, delete it, and rewind because it was really kind of tricky to divide 37.5 into 300. So I was like, how can I do this an easier way? So I actually looked at it and said, well, let's do some estimating. 37 is really close to 40. And 40, a compatible factor would be 320. So let's try 8. Let's just try it. So then I took 37.5 and I multiplied that by 8 because it was way easier than doing long division. So 5 times 8 gave me 40. 8 times 7, 56, 57, 58, 59, 60. 24 plus 6 is 3, 30. Move my 0 1 decimal place, and it is 300. So, double checking my work, 300 divided by, let's see, get my laser out, 300 divided by, if I think backwards, 37.5 gives me 8. So 300 divided by 37.5, because I'm just using my basic fact families, gives me 8. Tricky problem. If you need me to explain that one to you, go ahead and raise your hand and I'll come help you out with that one, because it was kind of hard. Okay, now you guys got your triads. Were a lot easier than my example. No long division. So all you need to do is first write your algebraic expression. Write an algebraic expression, then evaluate it for the 3 values. Do it for 1, do it for 6, and do it for 13.5. What I would do before you solve for these, make sure you have your formula right. So write your expression, and then play the video and see what my expression is. then go back and solve it, because you don't want to solve it if your formula is wrong, because then they'll all be wrong anyway, even if you solved them right. Okay, so go ahead and try that now. Okay, so let me show you how this formula would look. 13 more would be 13 plus the product of m and 5. Now I can write the product, or the times, which is times, m and 5 in many ways. I could do parentheses, m times 5, but I don't have to. I could do 13 plus 5m. That's probably the way that I'm going to do it, because that's nice and easy for me, but you could do 13 plus 5 times m. You could do that as well. You could even move this 13 over if you wanted to, if you like it better this way. Because of your order of operations, you're going to do your multiplication first anyway. So that's a couple of different ways you could do it. So hopefully you have something along the lines of 5m plus 13 as your expression. Now I'm going to go ahead and solve it using our 3 different variables for m. Let's get a new slide up here. So if I have 5m plus 13, sorry for that weird looking 3. First I'm going to solve it. M equals 1. If m equals 1, 5 times 1 plus 13, well, that's easy. 5 times 1 is 5, plus 13 gives me 18. Check, we did one of them. Now I have m equals 6. 5 times 6, because I substituted my 6 in where my m was, remember? 5 times 6, because m equals 6, plus 13. 5 times 6 is 30, plus 13 equals 43. Not too bad. Told you guys had a much easier one than I did. Last one is m equals 13.5. So if I have 5 times 13.5 plus 13. Remember, I have to do this first. I have to multiply those together first because of the order of operations. 13.5 times 5. Do it on the side. I got 67.5. Hopefully that's correct. And then I just need to add 13 to it. Please do not make the mistake of putting 13 right here. That is wrong. You have to line up your decimals. So, line up my decimals. I just added a 0.0. I don't need that, but I just added it for fun. 5 plus 0 is 0. Or sorry, 5 plus 0 is 5. Obviously, it's getting late over here. 7 plus 3 is 10. And 80. So our answer for m, when m equals 13.5, our answer would be 80.5. All right, I hope you guys were successful, at least for the most part. If you have questions, be sure to ask me. This stuff is very important because we're going to continue to build on this, not just now, but as you get into middle school and even high school, they will continue to build on this algebraic understanding. So make sure you really know this stuff, okay? I hope that this lesson was helpful and that you learned a lot. Thanks, guys. Have a good day.